So I will solve the oldest exam I had, which is I think 2016, 2017 or something. So it's the oldest exam I have from the uni. Unfortunately, the camera sucks, so I won't be able. The question won't be that clear, but I will put the link in the description of the video. The first question, this exam should there's five questions in this exam. And it should take around 3 hours to solve this exam, but I hope I can solve it around 1 hour. I hope that I can solve it around 1 hour. So let's start with the first question. So the first question, a curve in the x and y coordinates is represented in a parametric form by. So you have a x, which is t cubed minus 3t. This is the x. The parametric of the x, and this is the parametric of the y, which is 3 times t squared minus 1. Identify the first question, part I, which is a location at which the curve crosses x axis and crosses y axis. So this question, this is part I don't want to waste that much in the time in the first part. So crosses the x axis. Whenever someone says to you cross the x axis, your first thing is to do like put y equal to 0. Y equal to 0. So y of t equal to 0. This means that t squared minus 1 is equal to 0, thus t is plus or minus 1. And from that, you want the coordinates. You want x coordinate and y coordinate. So you have the time, so it's not time. You have the t, which is the parameterization of the parameter, and you put the parameter back into the x. So x of 1, you get x of 1 is equal to 1 minus 3, which is negative 2, and x of negative 1 will be equal to negative 1 plus 3, which is 2. So you have the first point. What is this? You have first point, the second point, the x intersection. And you have y equal to 0, y equal to 0. This is always. And you have 2 points. The first point is t at t equal, because it's a parameter, it's always good to write like this is at t is equal to negative 1. We'll have 2. At t is equal to 1, you will have at t equal to 1, you have negative 2. And the closest y axis, again, easy. You have x of t, you put it equal to 0. This is meaning t squared d cubed minus 3t is equal to 0. Solve this equation. You find t is equal to 0. Our t is equal plus or minus the square root of 3. This is the second one. From this, so anything, what's the x-axis? What first thing you think about? Put y equal to 0. Go to it, y equal to 0. You find the time, or to find the parameter in which y equal to 0 happen, which is positive and negative 1. And you find the x corresponding x value. For the y axis, put x equal to 0. You find the parameter and you find the corresponding y values at this one. So as t equal to 0, this is the x intersection. You have the y intersection. The y intersection, you have 3 solutions. Each one of them correspond to a different t. You have x equal to 0. In all of them, x equal to 0. So 0, 0, 0. And at x equal to 0, you go to the y. This is 3, 0 squared minus 1, which is negative 1. So this is negative 3. But t is equal to 0. This is very important because it helps you graphing the thing, the function. At the square root of 3 or negative 3, you can actually see because it's t squared, so this should be the same solution because this one is even. So if t is to give you one value, negative t will give you the same value. We can actually try it. So it's square root of 3. 3 minus 1 is 2, and 2 times 3 is 6. So 6 and 6. I'm equivalent. So 3 minus 2 is 2. 3 minus 1 is 2. 2 times 1 is 6. So you find the x intersection, you find the y intersection, and this is part I. You get 1 mark with this thing. Easy ball. The second part is find an expression for dy dx. So first thing, let's divide the question. Is find an expression for dy dx. How can we do this thing? Boom, boom, boom. It looks a little bit complicated, but it's not. So you have the expression again for x of t, so for deleting that is t cubed minus 3t, and you have expression for y of t, which is equal to 3 times t squared minus 1. You can understand the way, or you can solve. So you can solve it my way. You can solve it the way it's been solved in the exam, the question book. You know that you can actually find dx as differentiate dx. You just write dx and differentiate the right hand side of x with respect to t. So it's 3t squared minus 3. That's dx, and then you multiply it by dt. Oh, this is dx divided by dt, and dy will be equal to 6t dt. You differentiate the y. So sorry YouTube, don't delete my video. You differentiate this thing with respect to dt, it becomes 6t, and this thing is dy dt. So the question wants dy divided by dx. So this is dy equals to 6t divided by dx, which is 3t squared minus 3, and dt will cancel. So this is dy divided by dx. And hence find the xy location at which dy divided by dx is equal to 0, and this thing equal to infinity. And thing equal to infinity if the denominator is equal to 0 and the denominator is not 0, and it's 0 if the denominator is 0. So dy divided by dx is 0 if and only if dy is equal to 0, and dy is 6t dt with this thing, so 6t is equal to 0, thus t is equal to 0. And we want it to be, the magnitude of it will be infinity, so we go and put 3t squared minus 3 equal to 0, and again we find that t is equal to plus or minus 1. We have to understand, so what does this mean to have a slope of derivative of 0? It means that a derivative will be horizontal if it's 0. If it's infinity, then the derivative will be vertical derivative. So at that location, it's very important to help us graphing. Will help us graphing. I will leave the graphing part because it needs all the information, and whenever I write information, I delete in the board because there's not enough space. Or I may make a pen video to see the solution. So at the x equal to 0, the derivative we expected, when the dy dx will be equal to 0, expected to look like this, something like this. And when dy divided by dx is infinity, we expect the graph to look something like this. It's like, if we do an ellipse, let's see an example. If we do an ellipse at this point, dy divided by dx is 0. Because we can think about it as like y does not change. You move a little small x and y does not change that much. And this thing, the derivative dy divided by dx as the magnitude will be equal to infinity. So that's it. That's when. So dx dy divided by dx is infinity. If delta x is like any function, if delta x is equal to 0, and will be equal to 0 if delta y is equal to 0. So infinity, delta x equal to 0, 0, delta y is equal to 0. So that the infinitesimal element of the curve has the length of this thing. If someone forgot, let's say someone forgot, oh, now I'm not going to delete dy dx. So this time I'm be smart, I won't delete it. I don't want to divide it again. So imagine someone forgot the equation of the wavelength, the length. We say, okay, what is the most famous equation for length or for the distance in math? It's delta x squared plus delta y squared plus delta z squared. So ds squared is delta x squared plus delta y squared. Because delta z squared is 0, because we don't have 0. We don't have z. So dx is just take the square root of delta x squared plus delta y squared and dy squared. So dx is this thing, and you have to square it, and the dy is the other thing, and you have also to square it, and that's a good thing. You know why? Because you see dt square and this thing involves dt, so we are actually in the right step. So ds will be equal to square root, take a square root, 3t squared minus 3 all squared. It's so hot, I want to take off my shirt. YouTube will ban me forever. So, nah. So, you square the first, so you have to square it. Expand this thing. 6 squared is 36. Oh, I just put it as it is. So we see the expression. The expression involves 3. So you can write this one. You can expand it. Okay, it's like the same thing, because at the end it won't matter that much. So 3 times 3 is 9. Times 2 will be equal to 18 t squared plus 9 plus 36 t squared, and we forgot everything. Delta t squared, we take it as a common factor between this thing and that thing. You square this one and square this one, square this one, square this one, and take delta t squared as a common factor, and it can come outside the square root. And from here we can see that there's negative 18 and there's 36. No, we forgot the integration sign for now. So 9t squared minus 18t squared. The t to the fourth minus 18t squared plus 9. And from this we can actually take 9 as a common factor. That's why I was thinking about it, to take it from the beginning as a common factor. But to say it, maybe it was some confusion. So t to the fourth minus t to the square plus 1. And we know the square root. If you have a square root of b, a times b. So have a square root of two things. It will be the same thing as square root of a times square root of b. So this thing is equal to square root of 9, and I don't forgot here delta t, and you forgot another delta t. Square root of 9 times square root of t to the 4 minus 2t squared plus 1. And square root of 9 is 3. And you have a square root of this thing. And you can see something. Something to the 4th. Then the term after it is that power divided by 2, and the last term is a constant. So what I'm saying is like, what's this thing? So what I'm saying is that this thing can be written as t squared minus 1. Think about it. T squared is to the fourth. To the time, the first time, the second is 2 t negative 2 t squared. Let's square the last one will give us back that thing. And this is square and this is square root, and 2 and the square will cancel each other. And we left us by 3 t squared minus 1 t times t squared minus 1. Let's see the question after that. And again, I forgot dt and I forgot another dt. I hope no one forgets it in the exam. And here's another dt. So we saw that infinitesimal element of the curve has the length, this one. So what we did so far, ds is delta x squared plus delta y squared and the square root is from Pythagoras theorem. We know delta x and we know that y, we square them and simplify the expression. And we know that the expression should involve square root of 3, this should involve 3, so 9, there is 9 common factor here, and 9 will simplify to 3. And this one, if you doesn't know that this one is gonna be this one, right now you're stuck in here, and you see this one. The only way you give the answer will involve this one is if this thing is t squared plus. So I'm missing a negative sign somewhere here. So here there is a mistake in one of the negative signs. So in one of them I forgot here a negative sign. So which one is the negative sign? So in one of them there is a negative. It's probably not this one, because this one is 2. So in one of them I forgot one. I'm fucking stupid. I'm so fucking stupid. So it's it's negative 18 plus 36 will be positive 18, and this will be positive 2, and this will be positive, so the last one will be positive. So yep, and they compare. Always put your mind to the last solution. If they give you something like this, put in your mind the last solution and compare what you're doing to the first solution. Thus you find delta s, and you say hence calculate the length between negative 3, let's go with negative 3 and 3. So if you find delta s, you find an expression involving t for delta x and for the delta s. So if last thing is you want to find the wavelength, that's physics. That you want to find the infinitesimal element of the curve. So we get ds and integrate it from negative square root of 3 to 3, and ds is just negative 3 the square root of 3 of 3 times t squared plus 1 dt, and this one will give us the solution for this one. And I don't want to do it because it's a simple matter of simple integration, which I hope everyone at this point know how to do a simple integration. I hope. So the last one will be equal to limit. Now let's go to the question B. So far we have gained, how many marks have we gained? As sketch I said I won't do it, it's easy. But because there's not enough space to do it. So far we get 2, and 5. So 9 grades so far. Easy grades, easy peasy. So limit when x goes I forgot to talk in Arabic. When x goes to negative infinity of e to 1 over x. Exponential functions like e 1 over x. And we know that the function will look 1 over x will look something like will look something 1 over x 1 over x will look something like this. So exponential when negative infinity goes to negative infinity, because I'm fucked up. It did not look either way. This graph is e to the x. This graph, this one e to the x. The other graph, which is this one, is e to the negative x, and neither one of them is 1 over square root of x. So how can we find the limit from this one? Actually, you don't have to do any graph for finding any limit. So 1 over x will look something like this and this. And you know that the limit when x goes to negative infinity of 1 over x equal to 0. So you know that limit and x goes to negative infinity of 1 over x is equal to 0. And e to the 0 is 1. So you don't have to do anything if you know that this fact is true. Because 1 over x, if it's either infinity or negative infinity, will equal to 0. Anything divided by infinity is 0. And e to 0 is 1. This is another 2 grids, easy 2 grids. And the last one is 3x squared minus 2x plus 1 divided by x minus 1, and take the limit as x goes to 1. With binomial, we have to pay this thing, you have to understand the pay very close. You can't use L'Hopital rule directly. You can't use it. You can't say, okay, I'm going to divide this, differentiate this thing and differentiate this thing, life is beautiful, and substitute 1 and it's over. It's wrong, because it's not 0 over 0. So you have to check first, is it 0 over 0, which is not equal to 0 over 0. This thing is a positive quantity, and this thing is a positive, something positive, divided by x minus 1. This is positive, no matter if you come it from the right hand side or come it from the left hand side. It's always positive, divided by this thing. This thing, if you come it from right hand side for numbers that's greater than, that means right hand side, you mean if you come straight from numbers greater than 1. For example, 2 will be positive divided by positive, which the value will be positive. But if you came to it from numbers that's less, if you came number less than 1, let's say it's 0, you'll get positive divided by negative, so it's negative. So if you came to it from one side, it'll be a negative number. If you come from it from the other side, it'll be a positive number. So, and it's not 0. It's not 0. It's just like this thing won't be 0. The thing will never be 0 because the numerator is always greater than 0. So this thing, the limit does not exist. Again, why the limit does not exist? Because if you came from it from one side, it will be positive. If you came to it from another side, it will be negative. And it's not 0. The numerator is not 0. It's not 0 divided by something. It's always positive number. So the limit does not exist. Whenever there's something like this, think about this way. Is it 0 over 0? No. So you can't use the L'Hopital rule. It's over. You can differentiate this one, you can't differentiate this one and take the limit. You can't do that. It's not 0 over 0. So you see this one. This one is always a positive number. It's always way greater than 0. So it's always positive number. This is always positive number. So positive divided by x minus 1. If you came from it from left hand side, which means less than 1, will be negative. The right hand side, it will be positive. So the limit does not exist. And last question is worth 5 grades or 5 marks, and we will end off the first part of the exam. Easy, everything is easy so far. With little tricks that can make people look smart, but that's math, you have to be careful, that's life. Complete the script. So what I do, take this one and put it here. So define the question, be organized. This life, like Jiu-Jitsu, be organized. this slide. So we have this expression and you want to complete the square. So take the first one. So take this one and take the square of the first one. First term, take the square of the first term. So the square root of 2 will be equal to the square root of 2. The square root of x squared will be equal to x. And you know the middle term is 2 times the first term, which is this one, times the second term that's unknown, will be equal to 2x. X and x will be cancel each other, and 2 and 2 will cancel each other. So b is equal to 1 over square root of 2, or square root of 2 divided by 2. Yeah, so I will write 1 over square root of 2. Just for quick checking. The first one square is this one. 2 times the first and the second is this one, that's 100% true. Plus second last one square. The last one square is 1 over 2. But the original expression is 1. So we're actually missing, for those two to be equal, we have to add another half here. This is completing the square for that one. Take first one, take the square root of first one. And the middle will be 2 times the first times the second, which is unknown, will be equal to that one. X and x always will cancel. And 2 and 2 sometimes cancel, sometimes not. So you solve the equation, get b is equal to 1 over square root of 2. And I want this time because it's easier to check. So you have this expression for completing the square. You get like 2 marks. The second part of the equation is you go back to the integral sign. 0 dx divided by square root of 2x plus half all squared plus 1, 2. Everyone, I think this year is so lucky. I'm lucky because they will give you the table of integrals. And you have all the expression. 1 over x squared plus 1 over square root of x squared 1 plus 1 minus 1, anything is given in the table of integral. So, but you see something that all of them will include 1, something plus 1. So what you can do is you come here and multiply by 2, and you come outside the integral and multiply by 2, because 2 divided by 2 is 1. So this thing will be equal to negative 1 half to 0 dx squared. And here, side note, if you have a times x squared, where a is a positive number, which means a is greater than 0, you can write this expression is equivalent to write the square root of a times x all squared. So once we come to simplify this expression, this will be 1 plus a square root of 2 times this thing all squared times this thing, all for everyone, for all of them, 2 square root of 2 plus square root of 2 times x plus half. And from this you can actually expand it and then make a u substitution. And after this one, always, for those questions, always make the u substitutions as u is equal to square root of 2 times square root of 2x plus half. So you can actually put this one, like expand it from here, and this one expand it. Then you can find du in terms of that stuff. Then after you find the du will be something, will be, in this case, will be equal to 2 dx. Because du, differentiate this with respect to u will be du, and this differentiate this thing, it's like the first question, and differentiate this thing with respect to the x will give us 2x. So 1 over 2 du equal to dx, because we know dx. So we will substitute the value of u for this one, and we substitute the value of dx as 1 over half du, And the last thing, you have to change the limit of the boundary for the integral. When x equal to half, you put it here and you find the value. And when x equal to 0, again you put it here and you find the value. And then you complete the question, because it'll be 1 over u squared plus 1. And that's one of the famous integral in the last page. And from there, it's an integral that everyone knows if you're not taking this course. And from that one, you can find the solution. And don't forget to take the boundaries. In this question, you may assume that x is a real variable. You have to read the question. So question 2. Okay, I'll stop, then put another YouTube video.